Question 2. What is the ratio of the lengths of the similar figures below? And what is the scale factor of these similar figures? So we want to get from smallest to largest here. So the ratio of lengths would be a 2 to 5 ratio, like so. So what is the scale factor of these similar figures? What we want to do is we want to do the image length over the object length. And in this case, I'm treating the larger star figure as the image, as in the enlarged or the thing that has changed, and the object original one was this smaller one. So the image length, so we're using this distance of the length of 5 centimeters, would be 5 over 2. And there is our scale factor. Question 3. Find the length of the side marked with a pronumeral using congruent triangles. Congruence means exactly the same. So we need to go and mark each of these missing sides as if the two triangles in question are exactly the same. The main thing you need to do is just being able to match up sides that you can see. So for example, on this one here, the side that's missing, if I was to line it up, we've got 110 degrees there, we've got 30 degrees from B to C. You can see those two angles. They will match up with Q to R. We can see 5 here matches up with 5 there. Therefore, the 2 must match up with this X. So X would be equal to 2 centimeters. With this triangle on the right, we can see here that we've got a triangle that the R corresponds with the S here, like so. So those are the same angle there. And we can see that the shorter side is 8. And so that must correspond here. We can see just basically from reflection that this must correspond with that side there. So X would be 8 centimeters. Question 4. Complete this statement: AB over AD, BC over blank, and blank over AE. In order to do this question, I recommend breaking this combined set of triangles into 2. There is a smaller triangle here. There's a smaller triangle there. And then there is a larger one here. So by splitting them apart, we can actually compare the two similar triangles. Now that we've drawn these two similar triangles, we should be able to see that the sides correspond with each other. So for example, A to B corresponds with A to D. So we can actually see how much it's enlarged by. So with these equations here, it's asking us to match up the ratios here. So the side A to B divided by A to D is going to be the same as B to C divided by which side? Or B to C is this bottom side here, and that will correspond with D to E. You can label it E to D or ED, though we tend to put it in alphabetical order. And the side that corresponds with AE will be AC. Find the value of the pronumerals. So the missing sides are going to be of the bigger triangle. We can see here it has been enlarged. Side A to B goes from 2 to 6. So we're timesing by 3. Therefore, the side DE, I'll put here, I was about to write ED there, is going to be the side BC times 3, which is going to be 3 times 3, which is equal to 9. The side AE is going to be the side AC times by 3, which is 4 times by 3, which is equal to 12. Therefore, the side AE, 4 plus G is equal to 12. 4 plus some number gets me 12. G must be equal to 8. AB and CD are parallel lines in the figure at the right. This is question 5. State the similar figures, calculate the values of X and Y. When you're asked to state the similar figures, you need to say what the two triangles are, and you must name them in the same angle order. And I'll show you what I mean. First, I'm going to split these into 2 triangles. We've got A, B, E, C, D, E. A to B goes 12. A to E is x plus 21. B to E is y plus 23. C to E is 21. D to E is 23. And C to D is 10.5. So those are the similar figures, because that is the reason we know this from a geometric point of view, apart the fact that you can see it and you can see that it will be lined up, is that if A and B are parallel lines, like so, that would mean that these would be corresponding angles. And so therefore, by that same rule, the other side, these two angles will be the same. And essentially, once we've got these angles that are the same, then when there is a corresponding side in between, we've got similar triangles. So if we have to state the similarity, as we do here, what we will say, calculate the values of x and y. So what we're going to have to do is find out what the how much it has been, how much the smaller triangle has been enlarged to get the bigger triangle. The only sides that can help us out will be the 12 and the 10.5. So I'll go from 10.5 to 12. So that's 105, a ratio 105 to 120. We should be able to divide that by 5. So that's going to get me 21 to 24. And so that's the ratio there. Or we can divide that by 3 and we get 7 to 8. Yep. So that means for every 7 centimeters of the smaller one, that's equal to 8 centimeters on the right. How this can help us is that would mean that for every 1 centimeter on the smaller triangle, this is equal to 8/7 of the bigger triangle. So 8/7 of a centimeter, or 1 1/7. And so what we can do is we can simply multiply the either side by this fraction. So let's start with the C to E. So we know that the A to E, the one that's got this missing number, x plus 21. So this is going to be equal to 21 times by 8/7, which we can simplify here. And that's going to be equal to 24. So therefore, what we've got here is that x plus 21 is equal to 24. Therefore, x must be equal to 3. And now it's time to go and have a look at y. So 23 times by 8/7 is equal to y plus 23. This one's a little bit more challenging here because unfortunately nothing really divides nicely by each other. So we're just going to have to do the multiplication. And thus y is equal to 23/7. Essentially what I've done there is I multiplied this side here, this 23, by 8/7, as I did before. That got me to this value of 184/7. Now some number plus 23 is equal to 184/7. So I just perform some linear equations. You can do this, of course, all into your calculator.